Hi, this is Group 24. We have Michael, Rex, and me, Cindy, here today. In this Vodcast, we want to give you a feel for what is the derivative and its concept, and then we will learn how to apply it in economics. It took thousands of years for the idea of the derivative to be formulated. Already in the ancient Greek, Aristotle had made changes as a central concept in his physics, and then in mid-ages, some physicists logically analyzed and classified the different ways that a variable could change. In the 17th century, Isaac Newton and Gottfried Leibniz developed the derivative through calculus. As one of the greatest ideas that we as a human have created to describe our natural world, the derivative can be used in many different fields. Firstly, in mathematics, the derivative is a way to represent the rate of change, which is often written using divided by the x. In physics, we can use derivative a lot in Newtonian motions, where the velocity is defined as the derivative of the position over the time, and the accelerate, which is the derivative of the velocity over the time. Then in chemistry, the one of the use in derivative is when we want to find the concentrations of elements in a product. Lastly, in economics, derivative allowed us to examine how revenue and cost change as the quantity produced and sold changes. Marginal revenue and marginal cost can help a business determine and compute these changes. Next, let's welcome Michael, who is going to show you how to apply the derivative in his uncle's business.
Hi, I'm Michael, and my uncle owns a bike shop. Because I'm such a great mathematician, I've calculated some functions for him. Now what we're going to do with my good friend Rex, the economist, we're going to interpret these functions and the results and show you what they actually mean. Okay, so here we've got the cost function. What I'm going to do is I'm going to derive this and I'll get the marginal cost function. There we go, c dash of x, that means the marginal cost function, 2x plus 5. Now I'm going to sub in 99 and I'll get 2 times 99 plus 5, which will equal 203. Now Rex is going to tell us what this means, because I don't even know, I'm not an economist.
So why did Michael derive the cost function? By deriving the cost function, that gives us the marginal cost. What is marginal cost, you may ask? Marginal cost is the amount by which a firm's cost changes if the firm produces one more unit of output. And that is the reason why we sub in 99 instead of 100. Therefore, this tells us that the marginal cost of producing 100 bikes is $203.
Okay, now we've got the revenue function. Once again, I'm going to derive it, and I'm going to get r dash of x, which is the marginal revenue function, 500 minus 0.1x. Now, once again, I'm going to sub in 99, and I'll get the equation 500 minus 0.1 times 99, and I'll get $490.10. Now, Rex, please explain, what does that mean?
So by deriving Michael's revenue function, that gives us the marginal revenue. The marginal revenue is the amount by which a firm's revenue changes if the firm sells one more unit of output. That is the reason why we sub in 99 instead of 100. What does this tell us? This tells us that the marginal revenue of producing 100 bikes is $490.10. But this may look like a big number, but do we really know if we're making a profit or a loss?
Okay, so to find out if we made a profit or not, what we're going to do is we're going to use our marginal profit function. So it's really easy to calculate. You just take the marginal cost function, subtract that from the marginal revenue function. In this case, we subbed in 99. So our calculation will be 490.1 minus 205. Give us the answer of 285.1. So basically what this means is after selling 100 bikes, we made a profit, a marginal profit of $285.10.
So as we can see, derivatives is a great way for businesses and economists to know how much quantity to produce in order to meet business goals.
That brings our presentation to an end. I hope you've learned a thing or two about derivatives and its uses in real life and economics. Thank you.